Hi there everybody, we are going to talk a bit of probability today, and specifically we're going to focus on something called the and or rules, okay? And that's based on the circumstances that you've been given, but something called mutual exclusivity and independence events. Alright, so let's just talk about those first of all. There is another lesson on mutual exclusive events, but effectively if the probability is mutually exclusive, that means they both can't happen at the same time, then the probability of A or the probability of B must be the probability of A and the probability of B, so plus the probability of B, don't say and. So the probability of A or B is the probability of A plus the probability of B. All right, so that's if the two can't happen at the same time, then probability of either of them happening is literally the probability of each of them happening together. All right, so if I put that into context, if I throw a dice, then if I took the probability of getting a head is a half, the probability of getting a tail is a half. Well, both can't happen at the same time, but if I say what's the chance of getting a head or a tail, well, it's half plus half, which is 1, which is a certainty, isn't it? All right, so that's what mutually exclusive means, and that's the and or rule, or the first one where it's or, okay? The other one is the idea of saying what's the probability of A and B happening. Well, if I think about the first one, I can't get a head and a tail. That's not possible, is it? It's just not going to happen. So in the idea of saying and for something which is mutually exclusive is not something that can potentially happen. However, if I said to you about the idea of choosing a boy with blonde hair, then I can have the probability of getting a boy, and I could get the probability of getting someone with blonde hair, and those two probabilities would be different, and they could be separate, and they are independent. One does not impact on the other in any shape or form. But if I wanted to say, well, what's the probability of getting a boy and who is also has blonde hair, so probably of boy and blonde, then we'd take the two probabilities and we would times the two together, and that would be the and rule. Okay, so you've got the or rule, which is about mutual exclusivity, and you've got the and rule, where two events are completely independent. All right, so they're the two rules, but let's kind of put them into kind of context. Okay, so if you pick a shape at random from the box, what is the probability I pick a square or circle? All right, well, I can't get a square and a circle. That's not going to happen anyway. So they are pretty much mutually exclusive. So that means I just need to find out the probability of A and the probability of B, or in this case, the probability of getting a square, the probability of getting a circle, and add the two together. Right, so the probability of getting a square is 3 out of 8, and the probability of getting a circle is 4 out of 8. So the probability of getting either of those two is going to be 7 out of 8. All right, does that make sense? All right, so you could have just done it all in one big go. You could have just thought, well, there's that one, 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 and therefore there's 7 out of 8. All right, but I want you to kind of get that concept of the fact that both can't happen at the same time, so I'm going to use this or rule, all right, the mutually exclusive one. Okay, so let's have a look at this particular one. So the probability Dan gets the bus is 0.3, and the probability that Emma gets the bus is 0.6. Well, does one impact the other? No, not necessarily. I'm sure they could both catch the bus as well. I'm sure they could both miss the bus as well. So this is not a case of these are not mutually exclusive events. They can both happen, or they can both not happen. All right, so these are independent events, so we can use the and rule. And this is what the question he's asking me. He's like, what's the probability of that and that? So it's a case of them both happening. All right, so what's the probability that Dan gets the bus and the probability that Emma gets the bus? So I'm going to use that times. Okay, so probably both and Dan and Emma get the bus is going to be 0.3 times 0.6. Okay, I times the two together. It gives me 0.18, and that is my probability that they both catch the bus. Okay, so what is the probability that one person gets the bus? Well, there's two ways this can happen, isn't it? Either that is a case of Dan gets the bus and Emma doesn't, or Emma gets the bus and Dan doesn't. So there's two ways this can happen, isn't there? Two ways it can happen. So I've got to look at both of those combinations. All right, so Dan gets the bus and Emma doesn't, or Dan gets the bus and Emma doesn't. So we've got 0.3 times 0.4. That's the probability that Dan gets the bus and Emma doesn't. All right, because you need to add up to 1. And then the other way around is that Dan misses the bus, so 0.7, and then Emma does, 0.6. And of course, because I've got two combinations, then it's those two added together, all right, because it could be that one or that one, All right, again, thinking about the or rule. All right, so we started off with the and, but because it's that one or that one, then I need to add the two together. Like I did in the previous one, when I said it was a circle or a square, I added the two results together at the end, and that's what I'm doing here, because it's either that option or that option. All right, so it's going to be 0.12 plus 0.42, so it's 0.54 is the probability that one person gets the bus. Okay, so these are just little rules. All right, they come and they need practice. All right, from you. So you'll need to go away now. And I suggest you go to maths-school.co.uk, where we've got a bunch of kind of questions for you to kind of have a practice on. But of course, if you need to revisit this lesson online, then please feel free to do so. All right, well, thanks for listening.